the algorithm of your and start working on it. And today's class, am I audible? I'm audible, right?
Yes, ma'am.
Okay. Okay, so the deep learning. Okay, so deep learning, the main models of deep learning are ANN, RNN, and CNN. Okay, so there are like autoencoders and reinforcement learning. All these are like are also a part of kind of deep learning. So the main thing is ANN, RNN, and CNN. So ANN yesterday is we saw, that is artificial neural networks, and RNN is the recurrent neural networks, and CNN is a convolution neural networks. And CNN can be called as convs also. I mean, some places they call it the same way. Both are the same. Okay, so these are the same things. So yesterday itself we saw what are neural networks, and so this how it is like they are trying to, I mean, even everything, not only ANN, even RNN, CNN, everything is based upon your human brain. Okay, so how your human brain works, they try to try to mimic the human brain, or to take a like a miniature of the brain. That is what they are trying to do. So like some of the problems in ANN they rectified in RNN, then in whatever the problems in RNN they rectified in CNN. But then the individually all have separate, I mean, they are doing separate works. I mean, it's not like that all the problems are rectified. Some features which ANN can't be done can be done in RNN, and something can be done in CNN can be done in RNN. So they all have the individual things. So I hope that you had gone through the ANN yesterday. Okay, so in ANN you had seen, so this would be the ANN architecture. Okay, so here you have the input layer and then hidden layer and output layer. So before the output layer, you had this weights and bias. Okay, and weights and bias are added with the inputs, and then what you had the activation function. Activation function was added. So here we saw the sigmoid function. Sigmoid is widely used in all the neural networks. Okay, so then after activation function, so why we use our activation function? To convert from the linear to the non-linear. Okay, so that is why we used it. In other words, I can simple terms, if I have to say, to get a proper range. Okay, so like a proper range from 0 to 1, or like -1 to 1, like that. So all this we saw in yesterday's class. So now coming to the RNN. So this RNN, so from the name RNN, you can see it is recurrent, right? Anyone can tell me what is recurrent? Anyone, any idea what that word recurrent means?
Occurring again and again.
Okay, so recurrent is like it happens and again and something happening again and again. I don't know whether any of you are talking or not. I'm not hearing anything. I'm audible, right? All of for everyone. Okay, I'm not getting any answers from you. Anyways, okay, so recurrent is some feature like it's happens and again. Okay, that is what we usually call it as recurrent. Okay, so now this uses the recurrent thing. So next, from the next slide, you will be understanding what it's like. Something happens like within again and again, same thing like that. So now here, this handle the sequential data accepting the current input data and the previously received input. So what is sequential data? So sequential data is like all the inputs are like depend upon each other. Okay, so everything, all the input depends upon each other. That is sequential data. Now if you take the cereal set, right? I mean, for the Diwali, Christmas, and all, you would be having, like, if you decorate the house with the cereal set data and cereal, not cereal set data also. Like, I can't take the example for some sets, like some usually now cereal sets also, like if one light goes, others will work. But before, I mean, so there are some kind of things like one kind fuses, one light fuses, everything won't work out. Okay, so kind of like that. Okay, so like if one input is taken out, I mean, one data is taken out, there will be a problem with all the data. It is highly dependent with each other. So that is what the sequential data is. And then here this needs all the inputs. So here this RNN can memorize previous inputs due to their internal memory. So here a special features of RNN are like from ANN, what you have seen is here the internal memory is very good, and it will take the all the inputs, because here all the inputs are important, because here what we are mainly working with is the sequential data. Okay, so now here when I see the major difference between ANN, RNN and CNN is ANN is like the tabular data. Okay, so the tabulation will be there, like rows, columns, like that. You have a tabular data, proper data. You have some certain features, and like a proper data, like kind of thing will be there. A tabular data. Mostly RNN can be working with the tabulated data. Okay, so like all the machine learning algorithms we saw, no, tabulated data, kind of tabulated data RNN work with, and this ANN work with, and in this RNN works with the sequential data. Sequential data is like kind of time series data, like the weather and everything, the timely data, wherever we record the time. This time we record the something with the time is called as time series data. Okay, so like in this time this weather, this time this weather, or something like that, which we record with the time. So all this time series data, it's quite important. All the inputs will have its importance. Okay, so those kind of will come in the RNN. And this convolutional, that is CNN, will be mainly dealing with the image data. So these are the major differences between ANN, RNN, and CNN. So you have to remember this thing mainly. Okay, so others, it will be like getting deeper and deeper. So now the main thing, you should know the difference between these three. The main also here, remember this ANN is for mainly the tabular data. That is, it works well with the tablet data. I am not saying that it can't work it. So in ANN also we work with other kind of data, but then the main principle or the main thing is that it works with the tabular data. RNN works with the sequential data, and CNN works with the image data. Just keep it in your mind, this thing. Okay, that is the main thing. That is why they have, because ANN was not giving a proper result for this sequential data and this image data. They try to find out these algorithms, different algorithms. They try to find it out. Okay, so that is also, while traditional deep learning neural networks assume that inputs and outputs are independent of each other, the output of the recurrent neural networks depend on the prior elements within the sequence. So here already I said, here each and every data points are important and they are dependent with each other. So now here this recurrent, so you are able to see here, right? So usually the normal neural networks will be this kind. Okay, so here this inputs will be given to the hidden layers, and then it will have so many functions happening over there. Then it will go to the other layers. The output will go to the next neuron. Okay, so now here a function like this will be there. Okay, that is called as a recurrent, a looping function. Okay, so this it again fit to back to itself. Some this kind of function happens in the recurrent. Okay, so here the distinguishing characteristics of recurrent network is that they share parameters across each layer of the network. Okay, so here they are sharing the parameters in the each layer of the network, but in that other case we saw this weight and bias will be having, right? And the weight and bias we are feeding it separately for each and everything, but here one weight no what that can be taken into all. Okay, so this is kind of thing, I mean, like when you only get a deeper idea you'll be understanding, but just I am just saying so that you just know what is the difference between all this. That's it. These weights are still adjusted and through the process of backpropagation and gradient descent to facilitate reinforcement learning. Recurrent neural networks leverage backpropagation through time PTT algorithm. So here actually in the other thing yesterday I told you what is back propagation, right? What is back propagation? I don't know why you people are not talking at all. I mean, all of you are there at yesterday's class, right? So back propagation, what I told you, right, is like the feedback system. So that's output, you from the output you get like a feedback kind of system. Okay, that is again fed so that you'll be getting that. So here this back propagation is through time because it's a sequential. Here this time always comes into place. Okay, so this we call it as here what algorithm we call it as BPTT, that is back propagation through time. So which is slightly different from the traditional backpropagation as it is specific to sequence data. The principles of BPTT are same as traditional backpropagation, where the model trains itself by calculating errors from its output layer to its input layer. These calculations allow us to adjust and fit the parameters of the model appropriately. BPTT differs from the traditional approach in that BPTT sums errors at each time step, whereas feed-forward networks do not need to sum errors as they do not share parameters across each layer. Okay, so remember here they this in this RNN they share the parameters. Okay, so here the sharing of the thing happens, and so here the sums or sum of the weight is taken, whereas there the we don't take it as sorry, sum of the errors taken, whereas in the on the ANN we didn't take the sum of the errors, we just directly pass the errors. So errors, I already told you what are errors. So, that whatever the input I wanted and sorry whatever output I wanted versus the or the difference between the whatever output I wanted with whatever output I got, that is kind of called as error. Okay, so here they are taking the sum of errors because here something called the parameter sharing happens, whereas there we don't take the sum of errors, we just take the errors and give it to the next input layer. Okay, so this is a in recurrent. This is I mean some of the differences from the ANN. And next, when you see here in recurrent neural networks, there are 4 types, like one to one, one to many to one, many to many. So all this you learned in mathematics. So one to one means you know what is like one input to and one output you'll get it. One to many is one input and many output. Many to one, like many input and one output, and many to many is many input and many output. Okay, so these are some of the types of recurrent network. So this one-to-one is also known as vanilla network, neural network. Okay, so where you have the single input and single output. This is most of the normal algorithms, like normal data, no? For that you can use this. So now like one to many is quite complicated, for that you can use the single input and many output you will be getting. So now here again many to one, many to many, so multiple inputs and multiple outputs. Okay, so these are the main features of RNN. I think one slide I missed or something. So next is the applications of RNN. So when you come for the applications of RNN, you have the applications mainly with the time series data. Okay, so the time series data, I already told you what is time series data, right? What is time series data? Just now I told you, right? I mean, why are you guys not talking anything? The last class, yeah. And you are just ending this last class and you can, I mean, you will be just doing the projects and all. Just now I told you, know what is time series data. Someone tell, I mean, why you don't speak at all? Any of you, just try what is time series data. The all the data which is associated with the time. So here I told you like weather forecasting and all this, you will be using this. Okay, and then the other applications will be like language modeling and prediction. Okay, so like language modeling in the prediction, like the like some words will be given and you will be able to predict the language and all those things, like whichever like language, like speech recognition, all this wherever the language is used, right? So and also the translation, the language you can translate, like the computer will be able to translate. Now I am speaking in English, it can translate into your native tongue. Like if it is Hindi, it would be translated to Hindi, or Tamil, it will be translated to Tamil. So all this, like, and also speech recognition. We saw yesterday itself, I told you the speech recognition. So like whatever thing I'm speaking, all right, I mean, it will be able to recognize and it can convert into text, or it can even like if it is like it, if it is like done very well, then it can even recognize who the person is speaking. All these things, it will like it will be taken. So all these things are some of the applications of RNN. And then comes the CNN. Again, the CNN, as I said already, so it mainly deals with the image. So image is the main concept of the CNN. So it has contributed a lot in the field of computer vision and image analysis. CNNs are a class of deep neural network that can recognize and classify particular features from images and are widely used for analyzing visual images. Their applications range from image and video recognition, image classification, medical image analysis, computer vision, and natural language processing. So this NLP, the natural language processing, will be done in the RNN also. So the RNN also is used for NLP, and CNN also will be used for the NLP. Okay, so natural language processing is another big thing. I mean, that is the like another big concept in the deep learning, which the works are like going tremendously, like very good works are going, because this is what like all the language things comes into that NLP. So here the RNN, CNN, everyone, everything will be used for this language processing. So here otherwise this is mainly into this. The CNNs are mainly into image. So image recognition, video recognition, image classification, medical image analysis, all these are done with the CNN. So image recognitions in the sense like So we are having, so if I'm having this cats, dogs and everything, okay, so I when I see with my eyes, when I see the my brain will tell me that it's a cat, or I will be able to distinguish, right? So similarly this computer should also distinguish and classify all these things. It comes under the which category, dog category or cat category, or what images I'm giving is a dog or cat. So all these things will be done using the CNN. So the term, the CNN, as it is said, that is convolutional neural networks. The term convolution in CNN denotes the mathematical function of convolution. So most of you would have studied this convolution in engineering. So you would have known what is convolution. So convolution is nothing but like it is a multiplication. It's a multiplication of two functions to give another function. Okay, so and here it is like it is here what we do is we multiply with the filter. And in CNN denotes a mathematical function of convention, which is a special kind of linear operation wherein two functions are multiplied to produce a third function, which expresses how the shape of one function is modified by the other. In simple terms, two images which can be represented as matrices are multiplied to give an output that is used to extract features from the image. Okay, just I will show how they are extracting from the image. So this multiplication, from the values, they will be able to identify the edges, and also those of you who have studied the image processing, digital image processing and all will be knowing, right? So all this image is represented in the form of pixels. Okay, so and then in the edges and all the curves and all, the pixels will be varying so much. So with that how it is varying, how bigger the numbers are, we will be able to identify. Okay, so where the curves and edges are, all these things we will be able to identify. So this is how it is. I think this is a picture we are seeing. Okay, we in when the normal eyes we see like this, but the computer sees like this. Okay, so it will be represented in terms of some values. So that is how it is. So now here, this picture you are getting, right? So this full picture is having the values like this. So the values will be having some variations when it comes like when the image is at this, these curves, these edges and all, know that the values will be having a tremendous variation. There will be some kind of variations than the other. Okay. So now coming to the architecture, the conversion tool that separates and identifies various features of the image for analysis process called as feature extraction. Okay, so the this already we studied about the feature extraction. A fully connected layer that utilizes the output from the conversion process and predicts the class of the image based on the features extracted in previous stages. So this is this feature extraction is we are going to extract the feature, okay, from the convolution function. This convolution is like you will be having the you will be multiplying with the filter. Okay, I think maybe I missed that figure. So okay, uh, so that when you are multiplying with the filter, then you will be able to recognize where is that feature kind of thing will be there. So you'll be able to do that. Okay. So now they're coming to here. This is a feature extraction part. The architecture, the main thing is the feature extraction part, and then you come into the classification. So here in the feature extraction, you will be having the convolution function. Okay, so and then you will be going to the fully connected. So this we will be seeing over here. So what happens in the convolution layer? This layer is the first layer that is used to extract the various features from the input images. In this layer, the mathematical operation of convolution is performed between the input image and a filter of a particular size. So that is what I told here. The convolution function is used between the input image and the filter. So the input image will be like this in the terms of number, and you will be using with the you will be using the convolution function. That is, you will be multiplying, applying the convolution, you will be multiplying with the filter. So by the sliding the filter over the input image, the dot product is taken between the filter and the parts of the input image with respect to size of the filter. The output is termed as a feature map, which gives us information about the image such as the corners and edges. Later, this feature map is fed to the other layers to learn several other features of the input image. So here in this thing, the convolution thing is nothing but you can consider these as the filters which are multiplied with the input image. Okay, so this is given. So from here, because of this, you will be identifying where the edges or curves are. That means you will be having some values, particular values varying rapidly, or so you will be able to see a difference. Okay, so with that you will be able to identify where the corners and edges are. So this will be again fed to the other layers. So this pooling layer. So next is followed by the pooling layer. So the pooling layer's main aim is to decrease the size. Okay, so for everything from like all the algorithms, you'll be having this reducing the size at the end, because you have to, like, otherwise there will be a problem of overfitting and all. So that is why, and also you have to reduce the computation cost. So always there will be the reduction function. So here we call it as a pooling layer. So here it is to reduce. This is for this is to decrease the size of the convoluted feature map to reduce the computational cost. This is performed by decreasing the connections between layers and independently operates on each feature map depending upon method used. There are several types of pooling operations in max pooling. So one of the pooling, there are so many operations. Most of the cases they use the max pooling. The max pooling, the largest element is taken from the feature map, whichever having the higher value, that they take from the feature map and they fed it into the next next layers. So average pooling calculates the average of the elements in a predefined sized image section. The total sum of the elements in the predefined section is computed in sum pooling. So here it's like max pooling takes the maximum, the largest element, and the average pooling takes the average of the elements, and the sum pooling takes the sum of the elements. Okay. So this is like, this pooling is used, like the main features are taken from the feature map. That is after the convolution, after you convolute between your input and this filter, you get the feature map. From that, some of the features which are important or you consider as very good are taken separately. We are not going to feed the complete feature map. We are taking in separately. That is what called it as pooling layer. You are taking certain features or land feeding and you are feeding it to the next layer. So this for reducing, you are just reducing the size in order to reduce the computation cost, because you can't completely, you can't fully take something and feed it, right? So for all the algorithms there will be this reduction will be coming up. So next is like this pooling layer is like a interconnection between your input and in between your convolution and the fully connected layer. So now next is a fully connected layer, consists of the weights and bias along with the neurons and is used to connect to the connect the neurons between two different layers. So here where comes the weights and biases. Okay, so like yesterday's class we saw, right, the complete thing about the weight and biases. So here we will be having the weights and biases in this fully connected layer. These layers are usually placed before the output layer and form the last few layers of the CNN architecture. In this, the input image from the previous layers are flattened and fed to the FC layer. The flattened vector then undergoes few more FC layers where the mathematical functions usually takes place. In this stage, the classification process begins to take place. So here you will be adding having the weights and biases, and then you will be one other step happens is the flattening. So flattening in the sense like you will be having you'll be having a like a matrix form of data, right? So like you will be having like so many rows and so many columns. So this you will convert into a column vector. Okay, so that is like a one single strip kind of, like that, a column alters. That is what called as flattening. Okay, so this steps happens over here. Like a flattening means like all this data will be having some in so many features will be like rows and columns will be there, so that you convert into a single strip, okay, or a single column. So that is called as flattening. So this happens over here in the fully connected layer. So this is just before the output layer. So, and the classification process begins over here. So next is dropout. The dropout is again, it's like to dropping some of the features so that in order to avoid the overfitting. From the name, it's we can identify. So usually when all features connected to the FC layer, that is fully connected layer, it can cause overfitting in the training data set. Overfitting occurs when a particular models work so well on the training data, causing a negative impact in the model's performance when used on a new data. To overcome this problem, a dropout layer is utilized wherein a few neurons are dropped from the neural network during training process, resulting in reduced size of the model. On passing a dropout of 0.3 or 30% nodes are dropped out randomly from the neural network. So here this happens in the training data set. You will drop out some of the data that you will identify with some certain algorithms, and you will be dropping out some of the things so that you will avoid the overfitting. So this is a feature used in this algorithm dropout. And then activation function, as I said, you have this is for like from the linear you'll be converting to the non-linear. So here also in this algorithm also you will be mainly using sigmoid function, and also some other function called softmax also generally used. Okay, here most of the cases in this will be using softmax. That is another activation function. Yesterday we saw about sigmoid, so this is another one activation function. So here finally one of the most important parameters of CNN mode is the model is the activation function. They are used to learn and approximate any kind of continuous and complex relationship between variables of the network. In simple words, it decides which information of the model should fire in the forward direction and which one should not at the end of the network. It adds non-linearity to the network. There are several commonly used activation functions. Each of these functions has specific usage. For binary classification CNN model, sigmoid and softmax functions are preferred. Uh, and then for multi-class classification, generally softmax is used. So here, in this non-linearity, they are telling us non-linearity network is same as that. You will be having a standardization. That is what we call this from your transformation. Transformation like in simple words, there we are using from the big high range like minus infinity to infinity. We were converting the range. So same thing. That is from transforming from one thing to other. That is how we are able to get the result. So here also from the linearity we are converting to the non-linearity. That is the main purpose of the activation function. So here you can see this is like I mean a more complicated image than this. Okay, so here it's like input convention pooling fully connected and then directly got output. In this you could see the flattening. So here the flattenings happen over here. That is, I told you, right? So many matrices will be having in the matrix form you'll be having the input data. Here in the flattening you will be getting like a single column matrix or the column vector. Okay, that is a single strip you will be having. This is for feeding to the next time in the next layers you'll be using this kind of data. Okay, because it is very difficult to take it into so many matrix forms. So that is why you have the flattening step over here. And here they are using softmax as an activation function. And before that also this convolution, right? This convolution you are having this value. This is also an activation function actually. Okay, and then happens the pooling and then all this. These are the steps. Okay, whatever image here they are giving the input image as the car. So that is how it is happening over here. You will have different values for this car and other things. Okay, so that according to the values it will be able to identify which is the output. So that's it about this CNN, RNN and ANN. So the main thing over here is that you have to think is that this ANN is for tablet data, and then this RNN is for the sequential data, and this CNN is for this image data. And apart from this, you have the, like, ANN is normally used in almost everything, like all the learning algorithms and all. You can use it in the I mean, you can get it through ANN also, and like you will get a more appropriate result. And then this RNN mainly you'll be using for this voice recognition, music composing, all these things. And also wherever the time series comes, you this RNN. Then in the CNN, mostly it deals with the image data and the and this video, all these things, all the classification of images or identification of images and everything. Wherever the images comes, now you have this mobiles that you have you that you could see set your image as your password. So all these are like works of this deep learning. So like different algorithms are used. I mean, you like this ANN also they are using for all these purposes, but then they were not getting the proper results, so then they got it into this. So this here, and you see this reinforcement learning, this reinforcement also a big chapter. Okay, so in reinforcement is like you will be learned through some what I have to say, some punishments or rewards, we can say. So any output, if you are getting a proper output, you'll be like giving rewards. So with the rewards, you will be every time you get the rewards, you will be knowing okay what the way you are going is correct. So that is what a reinforce learning. Okay, so like so everything have an like a special kind of work or the special kind of use. So this is all about deep learning. So if your main thing is that you are going to mimic your brain. That is the whole purpose. Your brain could, like if it is like voice, it could recognize the voice. If it is an image, it could recognize the image what it is. So everything like all whatever that work the brain does, it the deep learning wants to do. That is why we are going very deeply over that you're trying to learn about the functions of the brain and trying to like establish it. So this is all about the deep learning. And anything else you guys want to ask about anything? And don't leave. I have to take the attendance 1 second. Yeah, guys. So project, I already, those of you had joined lately, just make sure that you do a project. I mean, I think Pranav and someone like some I think Kumari or someone. Okay, so I had sent me some things. So this weekend I'll be reviewing and I'll be sending that. And others, you just send me algorithm of your choice. It's better that if you could do all the algorithms. Okay, so it will be a practice for you all. So otherwise, just take your choice algorithm and you can do. I mean, you can do and you can submit.
Excuse me, ma'am.
And
When are we supposed to submit the project?
that's it. If you want to speak anything, I think
Hello?
today will be the last class. Maybe I mean tomorrow onwards they'll be starting the new batch, I guess.
Hello? Hello, ma'am.
I'm unable to hear anything. Pranav, are you speaking something? I couldn't speak anything. Sorry, I couldn't listen anything. Some problem. Okay, sorry. So guys, I think till now, I mean, I couldn't hear anything. So some okay. Now I rectified. So Pranav, what were you saying?
Ma'am, I was asking when and where are we supposed to submit the project and the algorithms? Should we mail it to
No.
you only?
Mail it to me. Mail it to me. Because again, I mean, new people are your Ankit sir and Tejas are not in the this thing. So mail it to me itself. And also this Google Sheets are not working also properly.
Yeah, ma'am. Actually, even the attendance link is not working. I've been trying since last week, but I couldn't mark my attendance only because the link's not working properly.
Yeah, today and yesterday she asked me to take attendance, to take the screenshots and send, but
Okay,
I don't
ma'am.
know. Yeah, before that I don't know what was going on.
Okay, ma'am. So then by when should we mail it to you? The project and all the algorithms because I had some doubts in the algorithms and all.
Okay, well, this week or I mean, you can take 2 weeks time, and it will be
Okay,
quite, yeah, 2 weeks time. You take it and you send it.
okay. And ma'am,
Ma'am, can you
is
just
there
please
have we
repeat the
do we
project
have to
part
do it on a
again?
specific algorithm or we can do it on our choice of
Take
algorithm?
any algorithm you take, and you try it out.
Okay, thank you, ma'am.
Yeah, thank you. And someone else was speaking, right?
Yes, ma'am.
Between.
Ma'am, can you please explain the project once again? I was joined late, so I have some confusion.
No, I didn't explain any project. I just told, like, we have seen so many algorithms, right? Like linear regression, logistic regression, A bias, decision trees. So many algorithms we have seen. There are some more like those of you who are learning machine learning and all. No, I see so many are from that background. So you would have learned some other algorithms, right? So the random forest, all this you would have learned like SVM and KN and all that. SVM and KNN already sir taught you, right? So anything, okay. So any algorithm you take and you take a data of your own and then you can do it if you are not getting. So there is something called Kaggle, okay, the Kaggle is there, right? You can just google it, Kaggle, you can get a large amount of data, but then there that data is like almost like the real world data, so it will be quite difficult for you to do it, but if you're doing it, it will be very very good. And also this Kaggle, no, they actually host some competitions also. So if you are able to do some of the competitions and all, no, so for all those things you have to go into much deeper and deeper. Here it's like what you were learning is like a very basic thing. So you have to, any algorithm you take, you have to dig it into the most deeper part, and then all you will be able to go to and crack the competitions. So if you are cracking the competitions, it is like you will be having a credit also. Also you'll be having, sometimes they give cash prize awards and all. Okay, so I mean, this is like another part, like other ways you can take easily the data from there. So there will be like worked out things also, worked out things also there, but then don't copy it. You can just take it as a reference. Like if you are copying, there is no use, right? So you can take it as a reference. Like if you are like those who are of non like machine learning students might be able to do it very easily. So others it is very difficult. So in the initial thing, so first it's like completely you have to be thorough with the algorithm, and then you have to be you have to know like the basics of the Python at least. Only then when you can check it. Like so many things will be like this analytics vidya, one thing is there. So and also like towards data science, that is these websites, not these two websites gives very nice presentations of everything. Like you will be getting a very good idea about it. And apart from this, if you are doing this course, this machine learning course in Coursera also, you'll be getting a very good idea about it, because they go into a much deeper part of it. But then actually this machine learning is not only concentrate on machine learning itself. Like this is like the main, I told you, right, this data science. So if you are going to the analytics side, like you like the basics is enough, because you'll be doing only the analysis part. Okay, so when you are going to the research and all these things, now that times this machine learning, deep learning, you have to go into much deeper side. So that is what all it is. So I mean, for this coming to the project, you can take the data from the Kaggle or something. So that is like you usually easily you can access it. Otherwise, if you are not getting any data, you can just contact me. Okay, so you can WhatsApp me or you can mail me. Mail means, I mean, like I won't respond immediately. Like if you are sending me the project, mail me. Otherwise, if you have some doubts or something, you just WhatsApp me, because that is what I usually use. Okay, so that I can respond to you. If you're not getting
Okay, ma'am.
the data, just send it to me. I will send you the data. Sorry. Yeah. My mail ID I had given already. Okay. I'll give it again.
Ma'am, can we just send you just the GitHub link so that we will upload, like I will upload my whatever
Yeah,
project
yeah.
I will
Yeah,
make, that
sure,
we
sure.
will
GitHub
upload.
link also you can send.
Okay, ma'am. Okay, ma'am.
That's what I said, no? I mean, you people, I mean, those of you know all these things, you can yeah, do it like anyway, GitHub link is enough. I mean, those of you are not aware, no, there are like many people are like not aware of all these things. So for them, I'm saying like you can, so, and also you can work at like any, like if you are doing it, collab also is fine, then PyCharm also it's fine, or Jupyter also fine, Anaconda, Jupyter, anything is fine. Okay, just you have to, like GitHub link is also fine to me. Otherwise, those of you who don't know about just GitHub and everything, just send me the code. Okay.
Okay, ma'am.
Yeah, you, okay, so just send me these things. Okay, and then like 2 weeks time you take it, and then you have to send me. I mean, depending upon all this only, they'll be giving the certificate, right? They are having some criteria like gold, silver, and so many criteria. So depending upon this, you will be getting, I guess. Okay. Okay. Thank you all.
Thank you, ma'am.